y is x to the fourth sine 2x cubed plus 1. We've got to find dy dx. Now, your first step in these sorts of questions is to decide which sort of rules we're going to use for derivatives. We've got quotient rule, we've got product rule, we've got chain rule. So we've got three. If we look at the function here, we've got x to the fourth, and there's a multiply understood there. Sine, there is no multiply in there. That's sine of this angle. So certainly we've got a function of x multiplied by another function of x. So we've got two functions of x. We've got this one here and we've got that one there. So we've got two functions multiplied together. What rule do we use? We use the product rule. So if y equals uv, so I'm just going through the thought processes that you should go through when you're looking at questions like this. So if y equals uv, we've got to know what dy dx is, and we've just got to know the rule. That's u v dash plus u dash v. And so we've got u is equal to this and v is equal to this second function here. Now, this second function, so this is u and this is v. This is not just a straight derivative of sinus cos, because we've got a composite function here. If I said, how do we know it's a composite function? If I said, given that x equals 1.1, and don't forget, when we're doing the derivative of trig functions, the unknown must be in radians. So if x is equal to, say, 1.1, how would you calculate this? Firstly, you'd calculate the brackets. Then you would find the sign. So you're doing two functions, so you've got a function of a function. So we're going to have to use the chain rule to find v dash. It's not just a straightforward cos of this bracket. You'll have to do the composite, the derivative of the composite. So it might be worthwhile just attacking the derivative of this. So if v equals sine of 2x cubed plus 1, we want to actually work out what v dash is. So we can say that let w is equal to the brackets 2x cubed plus 1, therefore w dash is equal to, so we just want the derivative of that, and that will be 6x squared, and the derivative of a constant is 0. And we'll let v equals sine of w, and so v dash, derivative of sine, is cos. So this will be, well, we better write dv dw. dv dw is cos of w. So this w dash is dw dx. So be clear about what we find the derivative with respect to. So we want v dash, which is the derivative of v, so dv dx by the chain rule is dv dw times dw dx. We substitute in dv dw is cos w, and dw dx is equal to times 6x squared. We've got to do a back substitution. W is equal to that. We probably should bring the 6x squared to the front times cos of w. Now w is equal to 2x cubed plus 1. Okay, that's how we've found the derivative of this composite function. So we've got v dash. So this is v dash. And now we can use our product rule and substitute in for v dash. Before I go on and do that, I'll just show you a quicker way. If v is equal to that, there is a rule, an acronym called DIDO, and that stands for diff in, diff out. What do we mean by diff in? is diff inside the brackets or underneath a square root if it's has a radical sign in there. So when we diff in, we find the derivative of this bit here. Find the derivative of that, and the derivative of that is 6x squared. Diff in times diff out. Forget about the fact that this is a function here. Derivative of sine is cos, and just write down bracket. Now that gives you v dash. So diff in, diff out is a shorthand way of writing, calculating the chain rule. Diff in, diff, we've got to be very careful to know what is in and what is out, but obviously in this one, inside the brackets is diff in, and diff out is just disregard the fact that you've got that 2x cubed plus 1 and just find the derivative of sine, you get cos. You don't have to use that rule. This will always give you the correct answer as long as you apply it correctly. All right, so now we're after dy dx. We've got to identify what u is. We've already got v and v dash, so we've got v is equal to that and v dash. So we've got u is equal to x to the fourth, so u dash is equal to 4x cubed. So putting it all together, we've got u and u dash, and we've got v and v dash. And all we're going to do is substitute in the rule up there. So it'll be u, pick up u is x to the fourth, v dash is down here, times, we might put that in brackets, 6x squared cos 2x cubed plus 1, close brackets, and I'll close the big brackets there. So that's u v dash plus u dash. U dash is 4x cubed. V we have to go back and pick up over here. V is equal to sine of 2x cubed plus 1. Maybe we should remove some brackets here, and we get 6x to the sixth when I multiply out here. I don't have to multiply, the x to the fourth is just multiplied by that because that is a multiply sign there. That is all one entity. So I just got to multiply that times that, and then put the cos of 2x cubed plus 1 plus 4x cubed sine 2x cubed plus 1. Common factors. Sometimes you'll see these answers and you'll see an extra step. I think if you get to that step, you've done very, very well. It's only just icing on the cake from here on in, and just to make it look a little bit better. There's a common factor of 2 that's common to both 6 and that 4, so I can take it 2. The highest power of x that's common here would be x cubed. Open a big bracket. What have I got to multiply the 2 by to get that 6 will be 3. What have I got to multiply the x cubed by to get x to the 6? Well, that'll be x cubed cos 2x cubed plus 1 plus, go back to this, what have I got to multiply that 2 by to get that 4? 2. What have I got to multiply x cubed by to get x cubed will be 1. We don't write that. And then just write that one. And just check that when you remove the brackets, you get the line above. Okay, that's looking a little bit better than what we've got up there, but I think if you get to that step, I think you should be right. All right, so be prepared for getting questions that not just have the product rule, but embedded in the product. One of the products will also be a chain rule. You need to recognize when you have the chain rule. And if you have to calculate that using 2 steps by calculating one function first, then calculating another function second, well, you know you're going to have the chain rule going on.